Alright, today we got interior and exterior angles that we're going to be talking about. So here's one of the theorems, the sum of the measures of the interior angles of an n-gon. So that's just saying like n number of sides. So you can use n as any number, 5 sides, 6 sides, 7 sides. You're going to use n minus 2. So you're going to take away 2 from the number of sides and then multiply times 180. Alright, you can do this with any polygon. Remember, a polygon is a shape with 3 sides or more. Okay, let's say that you had a regular polygon, whatever type of polygon you want. If it's regular, that means all your angles and all your sides are the same. So if you want to find an individual angle, let's say you had like 360 for a quadrilateral, once you found it, you could go and divide that by the number of sides that you have to go find each individual angle. So like in that case, if you're using a quadrilateral, 4 minus 2 times 180, you get 360, and then divide that by 4 to get 90 degrees for each angle, which will give you a square. And that's how you go find each one of the individual angles. Alright, this next one here, this picture kind of helps us out with this. For exterior angles of a polygon, those are angles that are kind of like outside of your figures if you extend the side. Those will always add up to 360. And the way I kind of like to think about it is think about a circle going on the outside. All the way around is going to be 360 degrees on the outside there. So, and that'll be for however many sides you have. You could have 5 sides like this figure. You could have 10 sides. It'll always add up to 360. So here's kind of a table of all the different number of sides here. Here's your generic n-gon right there, but then you have like triangle, quadrilateral, pentagon, and so on there. These are all your different angles. Notice that each time it's just going up by 180. So that's kind of a quick way to think about it. Alright, so let's go ahead and find a few of these. Here was the name of an 8-sided polygon. We're going to say that's an octagon. And then you can either use a chart up above, which actually doesn't even have 8. So you would just need to go and do your formula, a minus 2 and times 180. So that's basically 6 times 180, which gets you 1080 degrees. Okay, 9 sides, I think that's a nonogon. So that'd be 9 minus 2 times 180. That would get us 9 times 180, 1620. Or actually, I'm sorry, 9 minus 2, so it's 7 times 180. And that would get us 1260. A 10-sided figure, that'd be a decagon. Deca typically means 10. So decagon, 10 minus 2 times 180. That would get us, in this case, it's 8 times 180. So 1440. 12-sided, it's a dodecagon. And then that would be 12 minus 2 times 180, which basically 10 times 180, which gets you the 1800. I guess I should put degrees on all of those right there. So that's all you got to really do there. We can use what we know about all the interior angles and maybe solve an algebra equation. Notice here you don't have this third angle x, this last angle x. So we can say, well, the n minus 2 times 180, we can use that to find all the angles and then maybe subtract from that. So it looks like you have 6 sides or 6 angles. So that'd be 4 times 180, or 6 minus 2 times 180. And I think that'll get us 720 degrees. So that means all of that stuff needs to add to 720 degrees. So I'm going to write it out as x, and then plus 120, and then plus 100, and then plus 140. And some of you guys are just going to do this like right away in the calculator, and that's fine. Plus 120. Apparently that's going to equal 720. So most of you guys would combine those up before you actually write out the equation. I'm going to go ahead and start typing that in. That's wanted to show you where it comes from. and then I got 630. So we'll say x plus 630 equals 720. And then you would just subtract 630 from both sides, and then you get x equals 90 degrees. And obviously not draw on the scale, because that would look like a right angle. Well, that's really it right there. Find the measure of each interior angle of a regular octagon. So not only are we finding the sum, to find the sum you just do n minus 2 times 180. But if you want to find each, I don't know why I wrote that. If you want to find each, you take the sum and then you divide it by the number of sides. So in this case that would be 8. So say 8 minus 2 times 180. And then divide all of that by 8. And you can do that one line in your calculator if you want. I'm going to do it piece by piece so you kind of see. So the sum of the angles is 1080, but then you divide that by 8 to find each individual, and that's 135 each. And that would be your answer. Okay, and then each problem, similar in ways, but sometimes they're a little different. Look at this one here. Notice they say the sum of the measures of the interior angles of a convex polygon. We don't know what type it is, but it's 1260. Classify the polygon by the number of sides. So we know the answer is 1260. So what I'm going to do is just set this equal to n minus 2 times 180. Alright, now there's two different ways you can do this. You can go through and distribute the 180 there, but actually in my opinion it's a little bit easier. Instead of multiplying everything by 180, I'm going to divide both sides by 180 so I don't have to distribute. So I'll cancel out your 180s over there, and then we'll go 1260 divided by 180. Apparently that gives me 7, but that doesn't mean I have 7 sides. That means n minus 2 equals 7. So I'd have to add 2 to both sides, and n actually equals 9. So then it says classify the polygons, so then we'd say it's a nonogon. And then there you go. 2, solve for x. This is kind of similar to one of those ones that we did earlier. I know that inside of a quadrilateral, it's just one of the ones I've memorized. Quadrilateral, it'll always add up to 360. You just do 4 minus 2 and then times 180. But all that stuff should add up. So I'm going to do x plus, and then I'm going to type it out in my calculator right now. 71 plus 112 plus 135. I think it's just 318. And then equals 360. And then I'll subtract from both sides. And I think that'll be about 42. So x is 42, and then you're done. It's already got the degrees there, so we're good on that. All right, what do we got here? Find the measure of each interior angle of a regular pentagon. So 5-sided figure, if you want to draw a picture that helps you out, you can do that. Each interior angle of a regular pentagon, so that means all angles are the same. So we can find each individual one. So we'll do that 5 minus 2 for a pentagon, and then times 180. All right, and that's just 3 times 180, so I think that's 540. And then you're going to take 540 and you're going to divide it by the number of sides that you have. And then that'll get us 108. There you go. Now we can do an extension of that. Find the measure of each exterior angle of a regular pentagon. So if we think about one of the angles, here I'm going to use the same picture. If we think about one of the angles being 108 degrees, then the exterior angle, that's when you extend it, and those make a linear pair. Therefore, this exterior angle, this one, should be 72 degrees. Now, you have to do all this work first to get to 72 degrees, but there's actually an easier way. So I'm going to draw a little line down the page. This is how I do it if I'm starting from scratch. So say I got a brand new problem and I didn't know how to do it. We know that the sum of exterior angles is always 360. So if we go back and divide by the number of sides that you have, you can go and find those exterior angles, and that'll get you 72 degrees. So that's a much faster way to do those problems if you didn't already do the first part for it. So both ways to get you the same answer. So check this out. Classify the regular polygon by the number of sides if it has one exterior angle of 30 degrees. Now, there's a couple different ways you can do this here. I'm going to show you, in my opinion, the easier way. So I don't know what this looks like, but I know one of the exterior angles is 30 degrees. And then, we don't know how many sides, so I don't know how to draw that. But if one of them is 30 degrees, what you can do is take your 360 degrees and divide it by 30 to go think and work backwards to figure out how many sides you have there. And that'll get you 12 for that answer. And that's a little bit easier to do. Otherwise, what you'd have to do is you say, okay, well, this thing is n minus 2 and then times 180, but then divided by the number of sides. And then you'd have to set that. You'd have to set these two equal to 180, and that gets really messy really quick. So in my opinion, just do this right here. 360 divided by 30 divided by one of the exterior angles, and then you can go find the sides a lot easier. Okay, classify the regular polygon by the number of sides if it has one interior angle of 120 degrees. So it's kind of the same thing here, except we start with the interior angle. You can set the 120 equal to the n minus 2 times 180 divided by n, but once again, if we know the exterior angles are super easy to work with because we know that they always add up to 360. So I'm just going to say the exterior angle is 360. I'm going to divide it by 60, and then the only way that happens is if there are 6 sides. So in my opinion, use your exterior angle and then work backwards. Now, if you wanted to do it the hard way, here's the work behind it. You say 120 and then equals and then n minus 2, times 180 and then divided by n. And then you would have to make 120 as a fraction. Then you got to cross multiply. So 120n equals n minus 2 and then times 180. Distribute, this is a lot more work here. 360, 120n, subtract over the 120, add the 360, and then look at this here. At the very end, you're going to still have to do 360 divided by 360, or 360 divided by 60. So why don't you just do it the easy way first, and just start out with that. So, in my opinion, makes it a lot easier if we do that. Okay, you got a couple of extra algebra examples right here. So, just figure out how many angles you have. The number of angles will correspond to the number of sides. So 1, 2, 3, 4, 5, 6. So we need to do 6 minus 2 times 180, or 4 times 180, which I think is 720 degrees there. So we'll say 720. I'm going to go ahead and add up all the angles I know right here. This is 90, so if you want to write that. So we'll go 90 plus 124 plus 150 plus 93 plus 130. So that'd be 587. And then plus x, then equals that, and then subtract from 720. And then divide, or actually you don't need to divide at all because you just have x. So that'd be 133. If I added that up correctly. So let's see what's going on with this one here. A lot more junk going on here. Notice that you got all of these right here, just regular numbers, and then you got a couple of them with x's. So we'll start adding some of that up. So what do we got? 133 plus 167 plus 138 plus 115 plus 151 plus 120. So that'll be 824. The x's, when you add those, what do you get? 32, I think. It's 32x plus 824, and then equals, and then let's see, 1, 2, 3, 4, 5, 6, 7, 8 angles right there. So technically, this is an octagon. It's not a regular octagon. We'll go 8 minus 2 times 180. And that gets us 1080. And then we'll go 1080 minus 824, subtract that over. So 32x equals 256. And hopefully that's divisible by 32, and it is. X is equal to 8. And I guess that was all it's asking for, solve for x. I'm assuming they didn't give us instructions there, but okay. Here we go. Let's see what we got going on. 1, 2, 3, 4, 5. So this is a pentagon. So 5 minus 2 times 180. So it's 3 times 180. Which was at 540 degrees. So all this stuff should add up to 540. So I'll add up all the numbers, all the constant stuff right there. So 139 plus 71 plus 92 is 302. And then plus, you got, what was that, 14x, and equals 540. So then we'll subtract and then divide. 14x equals 238. And then divide that by 14. Hopefully that comes out nice. It does. X equals 17. And there you go. Alright, and I guess we have some special right triangle reviews. So I guess we'll do a couple of these. 30, 60, 90 triangles. So remember we put A, root 3, and then 2a for this side right here. So notice your root 3 side, a root 3 is equal to 8 root 3. So you can just divide both sides by square root of 3. So a is equal to 8. Therefore 2a is going to be 16. Here you go. Okay, number 2. 45, 90s, you got A, and then this is your A root 2 side. So this is one of the ones that doesn't come out very clean. So you're going to have to divide both sides by square root of 2. If you want to recap on any of the special right triangles, I believe that is unit 6, so you can go check out those videos there, unless we change our units around. And multiply top and bottom by square root of 2, so that's 12 square root of 2 over regular 2, and these do reduce. So that'll be 6 square root of 2, and that'll be for both of these here. So 6 square root of 2 and 6 square root of 2. See what's going on with the 30, 60, 90 down here. Got your 2a side, you got a across from your 30-degree angle, and then you got a square root of 3. So if 2a equals 48, that means regular a equals, what was 24. Alright, so then that side's 24, so this is 24 square root of 3. Alright, last one here. This is one of the ones here where they give us the a root 3 side is 12. So we'll have to do a couple steps here. So we'll need to divide both sides by square root of 3. And then we'll need to rationalize. So multiply top and bottom by square root of 3 over square root of 3. So that's 12 square root of 3 over regular 3. Reduce. That's 4 square root of 3. That is for your A side. So this side's 4 square root of 3. You need to double that, and you get A square root of 3 for your last. And that is it there for your lesson today. But that was kind of a review there. So main idea, all exterior angles are 360. There's that there. And then n minus 2 times 180 to get the sum of the angles. And then each angle, as long as it's a regular polygon, you divide by the number of sides. That is it.